Hello. So there was no announcement today, and I'm a minute late. But here we are. It's Sunday, and we're going to code some database today. Feel good about that, and should be fun. So just to recap, while I get my editor restarted, because it wants to upgrade basically every other day, it seems. The we left off last time, and we had a bug, and our test was showing the bug. And the bug that it was showing was that we expected to get key 0, basically, and we got key 1. And I think that it should have been obvious at the time, but I figured it out like 10 minutes after I ended the stream. As these things sort of go, like, in work, I often will be puzzling over something and then, be taking a walk or be getting cleaned up in the shower, and the idea comes to mind. So let's have a look at what was changed, because I already made the fix, I think. But we're going to dig into that, and we'll see what was wrong with that test. Okay, so let me get set up here. And for those of you who are new to the stream, welcome. Please say hi in the chat. And let me switch over to our main screen. So this is what we're working on. We're working on a port of HanoiDB, which is a key value storage engine. We're porting it to Rust. And I've talked in previous streams about HanoiDB, its design, why it's interesting, and we have basically implemented it following the patterns that we had in the Erlang version, but we took some digressions in some other places. For example, using a different kind of Bloom filter, encoding that Bloom filter in a different way than you would in Erlang. So we're pretty far along, and we just started to get the scans working. So if we go down here, there's a test. So this is a test that we had added but not committed last time. And if I do git show, this is what we committed last time. We made the top level scan method for the database, which returns an iterator. And we made it iterate in each level over the files from newest to oldest, so that we can make sure that if there's a key that overwrites an old one, then we get the newest version of that key. And we created a scan module. We made this nursery data type public, so that we can clone it and put it in our scanner. And then we created this whole scan module. Without going into too much detail on that, basically the idea is that we iterate over all levels at the same time. And when we are iterating over a younger level, then we are also, if we hit a key, because these are unique, the keys need to be unique across the entire database, at least effectively unique. In storage, they're not unique, but they're effectively unique across the entire database. So if we find a key in a younger level of the database, then we need to consume that, so remove that key from the iterators at the other levels of the database. And so we do that by basically within a level. I talked about the different files, the C, B, and A files that are in at that level. We consume those on a per level basis, but we also consume keys across the entire database. So we've got lots of iterators going on across a ton of files. This is an expensive operation. Just bear in mind, this is not cheap. And so it's not something you would want to do regularly. It involves potentially a lot of space utilization, because we hard link files so that they can be stable snapshots. And then on top of that, you're also doing a bunch of I/O to scan. So if that stuff that you're scanning is not in memory or doesn't fit in the operating system page cache, that could be really bad. So those are things to consider, and we're not even close to doing any optimization on that level. Just fair warning. Okay, so our full database scan test is really simple. It writes 30 keys. We're going to have to bump that up. And then it tries to scan the entire database and counts the number of keys it gets back. And as it's enumerating the scanner, it should get key 0, key 1, and so forth, just like we did up here. And what we were getting was, nope, we expected 1 and we got 0. All right. Well, let's look at what the differences are. And I did save it, okay? Let's look what the differences are on scan.rs, which is where the fix was made. Sorry. Well, it doesn't think there's anything different. This is just all uncommitted. Git status. Okay. Let's just do git diff. Okay. So it looks like there was a small change there. And I'm going to have to refresh my memory why. But one thing that we did was that we used peek. This is the first bug, I think. We used peek on the nursery. But then after we found that there was a key there, we did not consume it, right? So we needed to consume this this key out of the nursery. And the reason why I'm calling that out, because with 30 keys, we have not, if we just wrote 30 keys, we have not filled up the nursery and pushed anything into the first level. It just wasn't happening. So we were essentially iterating over the nursery on this iterator. Now, if we weren't consuming that key, if we're just peeking, so we're just looking in and grabbing to see what it is, then we were never removing it from that iterator. We were never advancing the iterator. So that's why we were expecting 1 and we got 0. Pretty simple thing there. And I want to look into, there was something with this. I think there was an off by 1. Right. Okay. So when we're in the nursery, we call this consume level keys, which note up here just takes the start index. When we consume level 0, or rather the first like indexed level, we want to remove this key from all of the iterators that are at any level beyond the nursery. But what was happening before is it would add 1 to that. So we would potentially skip the first level and not consume that. That was a bug that hadn't surfaced yet, obviously, because we didn't fill up the nursery to write to the first level. But this would have bitten us in the future. So I moved this +1 into this spot, and then here we can call 0 and we're guaranteed to get the entirety of the set of levels. Okay, so those are the 2 bugs, and here, obviously we're not using the nursery key, nursery value here. We just use the key for comparison, and then and so we don't need to pull it out twice. Okay, and then there's our whole test, right? So let's give that a whirl. It wants me to restart Z again. Isn't that fun? and it passed. So now I want to change the test, and this is going to make it run longer. I don't know that there's a better way to do it, but let's do let num keys. Let's do 1024 like we do in the lots of writes. I think we do 2048, yeah. And then we're going to say we iterate all the keys. Now this is not going to exercise the overwrites. So we're going to have to make a different test for that. For going, oh, we're going to scan the entire database, but we have newer things in the nursery, so we should get the value in the nursery, right? Rather than the value that was previously inserted. So we're going to have to do some tests like that. And we may even have to, at some point, if our file system or our file format is stable enough, we might have to have some snapshots, like create some fixtures that we load, and then like copy the directory to a temporary directory, load that database, and then make some changes, and just be certain that we don't have to write that every time. But let's run let's just run cargo test again. Now the test is going to take a while, both because we are writing a lot of keys, but also because we're iterating through all of them. So yeah, we went up order of magnitude. Okay, so it failed. So we have something new to fix. This is good. All right. Unfortunately, these are bytes, but we could say, so this is key dash okay, we might just have a little discrepancy between our formatters. And actually the issue is we need more than 2. Now that we're writing 1024, we need 4. So let's change that to 4. This is a test failure, by the way, not a so it was trying to truncate. Yeah, let's try that and see if that works. If that doesn't work, then we have some other bug going on, and we're not holding the ID in that. We can fix that. That's not a big deal. We just use it on initialization to name the files. Okay, our full database scan passed. Okay, so it was the key formatting. It was wrapping around or overfilling that field in the format. So let's make a quick commit, and then we'll fix those warnings. And I hope you all are having a good weekend. Getting prepared for the holidays, I know it can be stressful for a lot of folks. And I hope you're able to enjoy them. It can be tough. Okay, so we fix full database scans. And add the complete test. Okay. So, why does it still look like it hasn't been written? Or this is, we have warnings. Let's fix the warnings. Okay, minor warning. I don't know why I combined those. No, I don't want help. I want code actions, please. Oh, shoot. Okay. Let's go here. Yeah, we're not using that. And then here, yeah, that's never used. I say it's never used. It's just doesn't need to be kept around because we're using this to see the level scanners, and we just don't bother. We don't need to keep it around for any other reason. So now we could possibly make a method on this. It's like, you know, here's the ID of this scanner so that you can identify which hard-linked files it was responsible for. But we're just not using that at the database level. Let's see. You know, scan, it doesn't expose that type. It just says, hey, this returns a result of with an iterator whose items are keys and value pairs, key value pairs. So okay. So what we could get into next, yeah, that's small enough. I'm just going to amend because I haven't pushed that commit. Just amend it. So one thing I would love to do is have range scans. What that means is rather than just scanning the full database, we could still take a snapshot, right? But we would want to pass a you know, a range struct, something made with ... right, or ... equal, and then have the scanner skip to the beginning of that range, iterate through that range, and then as soon as, you know, the smallest key that it finds is outside that range, then stop. That would be really interesting. So let's look at what we have in the scanner and see what we can make use of to build that feature. Okay. So here's where the magic happens in the next method of scanner. And there might be some stuff that we can pull out of here. But we did a lot of semantic compression last time. And some of it was we wrote it really dirty. And then we made it better, right? As we got a better idea of how it should work. Excuse me. So right, so this, let's look briefly at the range API. So standard ops range. There's also range inclusive and range full. I'm guessing that there's, okay, so this range bounds trait is all we would probably care about. Let's look at this bound. Included, excluded, unbounded. Right, so maybe if we say that you could pass something that implements range bounds over slices of U8s. Right. Slice of U8s or vec of U8s. The thing is, we're getting entries here, so maybe vec U8 makes sense. Because if we have slices of U8s, then as the bounds, that would be kind of weird. Note that the start bound here returns a borrow of that type. Yeah. I don't know that we want to work directly with this. But let's look into this, because I think that we could I don't want to create a second thing like a bounded level scanner and a bounded scanner. I think that we could probably have it be optional when constructing this, and then if it's present, we'd have to do a lot of checking, of course. Let's go ahead and write a test for this feature. I think that would be important, because then we can kind of get an idea of what the interface should look like for a user. So I'm going to kind of copy this, and we'll say a database range scan is what we'll call this. And then what I think that I want to do is we'll make a new method, range scan, and have it be let's say lower bound is we'll make this be key, so we have 4 digits there. Let's do key 10 into bytes to have 2 string into bytes. Okay, and let's say the upper bound is, let's do 30. That's not very interesting. Let's do 100 or 200. There we go. And let's. I'm being a little bit vacillating there. So those will be our keys. And we want to give lower bound, upper bound. That'll be the interface. And then, here, we need to do a little minor fix here. Num keys. Yep. So what should we expect? We should expect 100 up to 499, right? Because this is an upper bound exclusive is the default with the dot dot. So we should expect 500 or 400 keys here. Okay, so and we need to add 100 right there. Let's see. Just for the sake of formatting, we know we're starting at 100. So, yeah. Okay, so this range scan method is not implemented. So let's start at the top and work our way inward. Okay, so we have scan, scans keys and values, where the key are in the given range. So what are these sorts of things useful for? You know, like secondary index type use cases. There are lots of things here. So what we want here is the range is going to be impl range bounds over vec of u8, right? Vec of bytes. And this should return a result impl iterator, basically this type. Let's just copy that. Okay, so this lets us say, you know, you can give an exclusive range, you can get an inclusive range, you can give unbounded, you can give, you know, you could give unbounded on either end, which is basically this, and which should inform you how we are actually going to do this. But this lets us have some openness to our API. So all the built-in range types implement this trait, and we just don't have to care about what it is. It does mean, however, that we need to potentially box this when we put it in our scanner and when we pass it around, because we're going to need we're going to need to operate on this in a generic way, but I don't want to write generics everywhere, right? We could. That's probably okay. Well, let's just do the minimum here. So we're going to change this range, and then up here we're going to put just dot dot. This says that you know, well, this is the wide open range. So we're going to change how the scanner is initialized, and let's say the range. Now there is potentially an argument to be made that we give this concrete type rather than using box. Note that doing impl range bounds, you know, vec u8 here, is the same as making this method generic and having that be the constraint, and this is R. The question becomes, that's completely unused. The question becomes, do we want to make like this type generic over the range? In which case we'll move this generic up to, you know, here. And then we have to propagate that generic everywhere. Or do we say range is a box dyn range bounds vec u8? And I think this is what we do for the first pass. And then interestingly, we may not need that. no, we do need to keep it around because we need to check it inside here. Okay, so I'm going to put range as box new range. Interesting. What's wrong there? Range bounds cannot be made into an object. Do we do dine? I'm forgetting how we do this. This is saying what we could do here is go. I think there's some multiple issues going on here. One of which is that this is just a constraint on the type or the trait, and not on the thing itself. Like, what is its lifetime? And I think that we might need to do clone. And now, yeah, range cannot be made into an object. I wonder if we have to do static here. Yeah, it still doesn't like that. Let's remove that. The main problem here is we don't know. What is it about range bounds? It says not dying compatible. Okay. All right. Well, then what we need to do is go full on generics. So we'll say R impls range bounds. I was hoping to avoid this, and this is just R. Okay, and then here we need to put this same generic here over R. And then we can remove this, and it's just range. Okay. Too many. No. There's no impl though. Okay. Minor syntax error there. Okay, so now we have to propagate this, right? This has to go here over scanner R. And anything else we implemented on scanner. Now we also have to pass this range to the level scanners, right? Because they need to advance their iterators internally to fit within this range. So we're going to have to do the same business down here. The other thing, range bounds does not, yeah, it does not require clone. So we're going to have to add that. Or what we do is we pass those by reference. Not my favorite thing to do here. We'll say AR. And this is actually not necessary on that, but we need this. Okay, and then here there's going to be a, we need those generics, right? And here we're going to have the range is going to be tick AR, and then we put the range in here. Okay, and this is fine because the top level scanner owns this range. These can just have a reference to them. And now it's just complaining that we didn't pass it, right? So here we'll do borrow range. And then I need to add those generics on the iterator too. So you can see how this gets kind of when you want to do something that has multiple implementations automatically through the compiler, you get these things where it's it starts to pollute everything. And it's kind of frustrating. We've seen this in the past on other projects, or earlier in this project even. Okay, so what's wrong up here? Nothing. It's just how we're calling this. Okay. So, and this needs to be R. Yeah, and this is a problem. Now, what we could do, and I think what is the answer is, we don't need to own this range at all. But we do need tick A on this. You see how like this gosh, it can be so frustrating to have this pollute your entire thing. Now, luckily, this will not go outside of. Right, we don't need to borrow that again. Okay, so this will not go outside this thing. This thing will only live in some relationship to the caller, right? So hopefully that's not a problem. Honestly, though, like I feel like I would rather just use clone, right? And here, right, there's some issues with. It's not an iterator. I didn't update that. Okay, that's the problem. Okay, now we need to add this tick A down here. It's just like polluting everything. Yikes. And we haven't even implemented the scanning, like the range limiting yet. Yikes. Okay. Let's find out what all the other errors are. Okay, so it captures an anonymous lifetime. I expected that might be the case. Which means we need to put this here. And this plus A. All right, and is that just dead code? Is that what that's complaining about now? Okay. Field range is never read. Okay, fine. Okay, so we can go there. Let's go fix that. Does the no? That's going to call up Copilot, and I don't want to do that. Let's go. Oh, please go to that file here, or we'll just. I keep forgetting we can edit it here. That is a cool thing about Z that I don't use that much. And same thing for this one. We can use the anonymous lifetime. And then what's going on here? Oh, this is part of our test. Okay, go back to the warning. I really don't like passing references here. Like, I feel like what we were trying to do is make it generic, and we ended up making it okay, fine. Let bounds is that. Borrow bounds. Like the thing that bugs me about this is these are most of the time trivially clonable values. Let's revisit this. Maybe there's a better way. So rather than I'm getting more. Rather than borrowing the range from the input, what if the scanner owns the range? What were we running into there? I don't think that there was anything, and because we made it generic, or rather, we made it generic rather than boxed. I think we can do this. And I'm wondering if this is the problem we ran into. What was it complaining about? Range does not live long enough. Can we do clone and say let that clone? Oh, right. I need to say plus clone. And now it still does not live long enough. Yeah, this is the problem. Now, we could just say, I don't care, clone it. Like, what do we have to lose? And then we can get rid of the... Well, yeah, now there's... Oh, this is why, right? Because we had to name this lifetime. You can have an anonymous lifetime there. Yeah, let's just not borrow. We're just going to enforce that it's clone. And then... no lifetimes. See, I went through all that just to remove it, because ownership is getting in my way. Right, okay, so now I'm gonna have to clone. Didn't they add trait aliases in recent Rust? I think they did. Anyway, oops, to make sure that this is all happy, even if we never clone it in the context of the level scanner, we have to provide that. Hi, Allie. Thank you. Thank you for coming. I have lots of content. I've been doing this over a year. We're doing Rust databases, and I appreciate you coming. Thank you. And I'm glad you just discovered the channel. So I hope it's helpful to you. We're making a database. Yay. Okay. So let me make sure that that did not blow everything up. Now down here, we need to, like, we don't borrow anymore because you can pass it. Let's make sure my signatures are all correct. That's not tick AR, that's just R. Okay. Let's look at the errors. Okay, so this is actually just wrong anymore. We just pass in the real thing. And here we don't need to borrow anymore. We just pass it. All right, what's going on here? There's no lifetime associated, so we can remove that generic. But here we need to do, say, it needs to be clonable. And now it's just complaining about never read. What's going on here? We can just pass the bounds. Okay. So now it's just, we're not using this range object that we've injected into our iterators. Okay, so now we need to go about the business of implementing this now that we've got the interface. But like, I feel like that exercise was really useful because the compiler was telling us, yo, this is not going to live long enough, or, you know, I don't know why range bounds objects are not dying safe. That's really curious to me. Yeah, not clear why those are not dying safe. Someone smarter than me should explain it. Okay. So we just have warnings that we're not using that range. So now we should go into, I kind of want to do from the bottom up again. Let's start with, I say from the bottom up, like at the small. So we've gone from the top down. Let's go down here. And now that we have this range, we need to look at how to deal with this. So okay, this I remember being quite simplified, but what we need to do is we basically need to do this algorithm. Except maybe it's like right here. We know what the smallest key is. Now we could potentially not pass this into the levels. Just do it at the highest level. My reluctance on that is a little bit that this is more complicated, doing it across all levels and the nursery. Um, this is more complicated than this one where it's just I'm within one level but up to 3 files. Um, when we kind of outlined what the strategy was going to be here. Now, alternately, what we could do, and this is probably simpler, um, we could, at initialization, go through each tree, because these are, you know, iterating over entries in one file, and consume their iterator until it's within the range. Let's do that. Okay, so we're going to say, still getting used to this new keyboard. Okay. When we say while, here, we'll say let tree is that. While tree dot peak let's see, dot map. So we're getting an entry out of there. So if this is an entry, key is actually what we want is not range contains key. So if it contains the key, we want to move on. If there's nothing in this tree, which is a case we need to handle, then we should bail from the loop right away. So we want to say unwrap or false. And then this is just tree. Now, another thing that we could do is sort of a take while. But that creates a new type. Right? We can use skip while. I actually think that I don't really like this pattern, but doing the work of advancing. Okay, so we know that range is evacuate, key returns. Right. Oh, shoot. We just do that. I don't really want to do that though, because we're going to have to do this on every single one, which is not fun. I thought for comparison's sake it would be fine. Although we might have to do... We might have to do U8 slices in this type. Let's see if we can do replacements on this. Probably not going to work. Lots of errors. Okay. Oh, well, I replaced the wrong things. Oh, first of all, let's fix this. I changed, yeah, this needs to be that Q8. I didn't mean to change those. Okay. And I didn't mean to change this, because that's what it actually is. Okay. Well, then we have an issue up here where this needs to be arranged over slices of U8. And then there's probably callers that mess that up. So we could do asref. Size is okay. The problem here, yeah, let's just back a bunch of this out. Okay. I think that I feel like this should... What is wrong here? Oh, I need to fix this again. Revert that. That's a minor fix. Yeah. Okay. Like, the problem with this is that the trait, the range bounds trait, is not using the borrow trait. Right, it's just saying that whatever this item is, the type in this bounds implements partial order over it. And this item also implements partial order over the contained thing and is potentially sized, but might not be. But it's not using, so on the, this is weird because on those collection types, like B-tree map, you note that like get has this borrow trait. And it just says that you can treat something as something else. So like this means that like in your B tree map, the key type can be like, well, in our case it might be vacuate, right, in the nursery. But if you call borrow on that key, you get type Q. And vacuate can be borrowed as a slice of U8. Or a good example, string can be borrowed as a stir. And that's how you can get that comparison. Whereas like here, you know, oh, that's not a good example because they're using integers. But the point of that borrow trait is so that you can have something inside your collection that is owned, but then you can check it against things that are borrowed, that are equivalent. So, you know, this borrow trait, right? So, example, box T can be borrowed as a T, while string can be borrowed as a stir. And they give an example down here in hash map, owns both keys and values. If the key's actual data is wrapped in a managing type of some kind, it should, however, be possible to search for a value using a reference to that key's data. So if the key is a string, then it's likely stored in a hash map as a string type, while it should be possible to search using an ampersand stir, a borrowed stir. So when you insert, the key has to, you know, implement this, and when you do get, it just has to be, they just have to hash to the same thing. So you can borrow, so it's saying K can be borrowed into Q, and then its hash compared against the hash of this key that you're passing. So then they give an example too of like this new type, case insensitive string, where you could say that you know, if you compare the inner string to the other inner string of this, you know, of same type, then you could say I'm sorry, I lost the thread on this. Right. So if the key wraps another value and produces a different hash than that value, then that breaks the hash map. So this is the main use case for borrow, and you'll see that they, you know, some useful things like, of course, a string implements borrow stir, and you know, path buff implements borrow path. This is incredibly useful for doing file system stuff. And then, like, you know, a reference to T implements borrow T, and a mutable reference implements borrow. Maybe there's so here's the issue then with range bounds. Is that it doesn't have this borrow trait in it. Let's see. Let's see if this bound. It has partial equal. It doesn't have partial ord on it. That's interesting. I suppose that makes sense. You know, this is just an enum over this thing. We might need to do our own comparisons here. Thanks for coming, Allie, and thank you for your commentary. You know, I'm here most Sundays, so I'll be back next Sunday, 1:30 p.m. Central Time, U.S. And I don't know if that's where you are in the world, but I'm usually here. Okay, so I think what I need to do, because our goal here is to make sure that this, trying to get back on track out of the docs and into this. What we want to do is we want to see if the lower bound exists. If it doesn't, then we don't need to do anything, right? So if it's unbounded, and then if we're gonna need mute tree there, right? Yeah. Okay, so let's do match. I'm gonna have to do this every time. Yikes. Okay. So start bound. And then we need to do, and let's oh, whoa, no. There we go. Okay, so if it's included and bound, or excluded and bound, actually I think this is going to be our comparator, right? And I think if we get it away from this contains method, we'll be okay. It's just weird to me that it doesn't have that borrow constraint on it. That's pretty... So let's make a comparator. And this is logic is going to be a little bit weird. Because what we want to do when it's unbounded is just actually we're going to do, let's put this up here. So here we're going to say none. This is much better. If it's included, then we want it to be, so this is like, this is an entry, entry dot key greater than or equal to bound. Otherwise, and this is going to be sum, otherwise it's going to be sum is an entry again, just for safety, key. If it's excluded, then we want it to be greater than that, strictly greater. Okay, so then we can do if let sum then we'll do our while tree.peak map comparator. And this is going to be this needs to be a barred entry. actually, we know what this is, but I'm gonna remove that constraint there because I don't really care, and I'll let the compiler figure it out. Unwrap or false. Okay. Type annotations needed. Well, what is the... Right, so it's a borrowed... Yeah. Okay, so now what? Oh, they don't have the same type. Fun. I think we need to box it and then see if it likes that. Nope. I did box it. Goofball. No two closures, if identical, have the same type. Consider boxing your closure. I just did. Why are you trolling me? I'm going to specify the type. Let's say dine, fun, entry, bool. All right. So what's wrong here? We just need to borrow it so it doesn't blow up. Okay. So, right. We remove that because we were going to do something else. Okay, so now, what's wrong here? Cannot move out of range because it is borrowed. All right, let's borrow it here. Or let's clone it. Temporary value dropped while borrowed. That doesn't help. Oh, what we can do here, I'm sorry, we can do cloned. And now this bound is a vec of U8. So let's borrow that. Very complex type. Well, let's remove it and see. I can put that in so that you quit complaining to me. Yeah. Okay, so type bound comparator. Jesus. And we'll say box, and then this is option bound comparator. Sheesh. Okay. We're doing a lot of type level gymnastics today. I did not expect that. So interesting thing here. I'm not positive that we need the move. Let's remove the move and see what happens. The move is usually, yeah, we need it. Okay. The move is so that you, like, this bound doesn't get dropped at the end of this expression, and then it's no longer valid inside this boxed closure. So the move ensures that it gets associated with this closure, and then it's no longer owned by the outer scope. What a mess. Okay, so now we have each level when it's starting up, as it gets each file in its level opened, it will advance the iterator from each file to the beginning of the range that is specified. So now, and we'll be able to do this at the higher level too, but now inside the iterator, we need to check whether the I think we can put it here. I think this is the right place to do it. Or it could be up here. Yeah, let's do I think it's we use this. So this is going to give us a usize and option U8. Okay. So this is going to be the key. Okay, if the range is not, if the key is not contained in the range that was given, like this is not complete, but ultimately we'll want to return none here, right? Because we have exhausted the range for this level. So, but this is an option of a bool now. So we need to say because we're basically doing the same thing as down here, right? We need to say unwrap or true. And again, we're going to have this issue. So key is a slice of U8. We're going to have a similar issue to this because I mean, we can clone that and then we can borrow it, and now it's Well, okay, we can say k dot 2vec and borrow that. I suppose. I don't actually care at this point. Like, I'm fighting with the fact that that range trait, the range bounds trait, doesn't have borrow on the contains. Oh man, that is so annoying. Maybe I'll make a patch to Rust. The problem, though, is if you try to make that sort of patch, then you're going to potentially break a ton of legacy code. And that probably only happens in additions. So anyway, we're just bailing early here. If the... Now we could... I'm just going to try this. We're going to try that, okay? If it's included bound, if it's unbounded, then we don't do anything because we need to continue until this is exhausted. If it's an included bound, then we want to say we'll get this. And we're not going to do range contains. We're going to say, oh, you know what? We might not need cloned here. We remove that. Maybe call bound deref on it. So this is the upper bound, right? So if it's included, then it's less than or equal to bound. Yeah, okay. So it's not complaining about that, it's just complaining about my return value. Okay. Actually, what we want here is if it's included, then we want to say if it's greater than that, then we want to return none. So this is the bail early condition, right? Okay, and then similarly here, it's this, but it's greater than or equal to. Nope, not arrow, greater than or equal to. Okay, so if you're inside the bound, then, I mean, this could go into the guard. Maybe we'll do that. That's a little bit crazy to go inside the guard. And then let's put this one inside the guard too. Return none, and then for anything else, we don't do anything. That looks ugly. Why are you not formatting? I'm going to try to put this on one line. Except it's not going to like it. That's fine. I just want to make sure that there's clarity here. And those don't need to be in curly braces. It's going to reformat it anyway. I just want to make it make sense to me. Okay, there's probably some syntax error that's preventing it from formatting. Oh, what? Oh, right. Okay, so we're getting rid of this. Yeah, no, it's like reformatting it itself. Okay, so if the bound is included and there is something in the, or there is a smallest key in this level, and it is greater than the bound, then we return none. So this unwrapper false is going to be like, you know, if there's none, then we just skip over this clause. If this map, it returns none. Same here, but if it's excluded, then if it's equal to the bound, then we want to not emit it, right? We want to return none. And then, yeah. And if it's unbound, then we don't care, right? If it's like key A through the end of the database, then we don't care about this. I wish I could tighten this up, but this is actually not bad. And then we can do similar logic except up here, except that we know that since all the levels have the did we already implemented that for scanner? Okay, no, we have something else going on here. We'll get to that. Okay, so we need to also, because we did that initial thing with the levels advancing past, or like into the range, we can do something here. Now the other thing to think about is that, like, there's a very clear optimization here where we should be saying to the tree entry iterator, start at this point, and then we'll probably get to that next time because we only have half an hour left. But that can actually be done much more efficiently because it can look at the inner nodes of the tree and like skip whole blocks that don't apply, which is nice. So we'll make that optimization next time, I think. But for this first pass, we just want it to work, and we have to start with the same sort of stuff we did down here. Okay, so except this is not going to be entry, right? So we actually have pair, right? Because these are keys and values, so we're going to say pair. Stop pretending they're entries. They're not. Okay, so now we can go how did we do it down here? Okay, we were going over multiple files, so we had to reuse the comparator. But in this case, we can go except this is pair.0, right? Because this is except this is not a bound comparator. This is here, let's rename this entry bound comparator. I'd have to create a new type for that, but like that's the only way to tell this this match statement that like, yo, these have the same type. It's a dine whatever inside. Okay, except this is going to be a nursery bound. And this is going to be box option. No, this is be box. Oh, dine, fun, evacuate. Borrow, I think, because it's peak. Peak returns, yeah. Okay, evacuate value to bool. Extra parens. Don't need that. Yeah, no, we do. Okay. So expected struck found. Okay. So peak. Okay, so this okay. What can I do to convince myself that this is correct? We're using the same logic here. We don't care about the value. Okay. Yeah, I think this is good. And then down here in the scanner, we have to look at we have to compare the upper bound here. So let's look through this logic. Yeah, it's just complaining about dead code. Okay. So here we're looking at what the keys and indexes are, sort of like what levels, right? need to be compared against one another. So so we know that this is the list of, here's the index into the levels, and here's its first key. And then we're finding which one of those is the minimum. And then we look at the nursery. So we're saying what's in the nursery is whatever is in the nursery smaller than the smallest key from the levels. Okay, so we need to handle we basically need to make this nursery iterator pretend that it's exhausted when it reaches the end of the range. But if the nursery is exhausted, I think we need here, I'm gonna go back at this windmill again. I think we need this because the note this case says down here, either the nursery is exhausted, so it was none, right? Actually, this needs to be here, not inside here. I'm sorry. If and so if the range contains the key that we just pulled from the nursery, and the smallest key from the levels is still greater than this key, then we choose the nursery. Otherwise, the levels had a smaller key, which we don't know yet if they do, or the nursery is exhausted. And this is a new case where the nursery is exhausted if that returns false. So I think that this branch is fine. Now we need to do similar to what we did down here up here. And I kind of hate this duplication, but it's honestly the same function. Okay. And then if the smallest key from the levels is out of bounds, return early. Return none early. Okay, so that's kind of the the other option that we could do is put something in here. Yeah. I'm noting that a little bit here that this is kind of like we should do, rather than wrap this in sum and return none on the inside plus an unreachable, I think we should probably switch this to a map, and then have an if statement in it with an unreachable on one branch. We can refactor that later. Oh, actually, the other reason why you can't do that is this. This continue says we need to go to the next value in the loop. So the key was deleted, which means we need to, like, we don't want to return. We want to internally in our iterators that scan over the database, we want them to return entries so that we can compare them across levels, but the ultimate interface for the user doesn't care about tombstones, so we don't want to return deleted entries. That's why this is not using map. So that makes sense. Yeah. Yeah, we could do something else like let entry equals this dot, and then put a question mark at the end. That's a possibility, and then have our code be a bit more in line. That would probably be clearer. Okay. Okay, I think what we've done, what we have, or what we can to handle this. So let's run our test, and I think that we're going to find it's probably going to break, and it may break other tests. So let's find out. Again, this is going to be slow because we're inserting a lot. We haven't done any optimizations on this thing. Okay, so the range scan failed. And what's going on here? So we have the prefix to every key. This is oh, I think it's just we're not getting the right thing. Note that this is 48. 48 is 0, and we got 49. So I think we just have a problem with our test. So left, no, we have a problem with our iterator. It did not skip to the beginning. That is not good. So yeah, it's not letting me pick that one. Boo. Yeah, I think Yeah, so we were expecting it to start with key 100, and it started with key 0. So there's something wrong with our initialization logic, I'm guessing. Yeah. Okay, at least the error is consistent. Okay, so this is a little silly. I think this is telling me that we're not accurately advancing to the beginning of the range. So what I want to do is look at let's just do ePrint line. And our problem here is I'm going to need debug on that. I'm going to do this because I'm tired of typing that everywhere. And this is going to be scan range. This is what I should have done at the beginning. I just don't really like making those trait aliases because they just introduce some indirection in a place that's not really desirable. Okay, and I would really love to have a minimal set of constraints, right? Okay. Okay, and then I need to do it. Order doesn't matter, but I'm just going to put it up there because. Okay. And now it's probably going to go like, yeah. Okay. My main point there is I want to like be able to do this, right? And then we'll just eprint a dot for every key that it skips. And we'll do the same thing down here in the level scanner. We will go advancing file to within range. And this is, and actually I can do scan file. Yeah, we'll just do that. Eprint. And it actually, these should just be eprint because I want to print the dots, and then we'll go eprint line. Okay, we'll do this, and we'll do scan file dot display. Borrow it. Fine. Oh boy. Okay. Let's go up here and do the same thing. Okay. This is really dumb, but I want to see the output, right? What's the warning? Private bounds. Yeah, I know. Okay, then there's no problems. Fine. This module is not exposed to users of the crate, so I'm not worried. Okay, so now let's run that test again, and what I want to see, I wish I could focus just this one test, and maybe what we do is one of these numbers, so we don't run the other tests. It's kind of dumb, but it'll get us there. And then when the assertion fails, we should get all the output. Except we didn't. Okay, so right, so it's advanced, so this is 0, 1, 0, 0, 0, 5, 0, 0. So the range is correct. It's trying to advance this file. It's advancing the nursery. But you note it doesn't advance any keys. So there's no dots trailing here, so it's not actually moving it forward. Which is strange. So let's go back and look at that, and then we'll wrap up. Hopefully we can figure out what the bug is. Another way we can do this is go while let some we can do some true. That's dumb, but Oh, here's the problem. Here's the problem. Our logic goes backward. Okay, so this should be less than, and this should be less than or equal to. And I think the same thing will happen down here, because like we're comparing what the key is to what the lower bound is, and we want to keep advancing until we reach that bound, right? And I think the same problem down here. Yeah, it's that this is reversed. So and then let's run this, and we're probably going to see a ton of output, but it passes. Okay, so the problem is that we had our logic backwards. That makes sense. You know, when you're building this new, like, it's easy to make that kind of mistake. And this is a complicated thing to think, like, to conceptualize, especially when the range bounds trait was not helping us. And we had to go with, well, what's the bound? And then do the comparison ourselves. Really frustrating. Okay, and then I removed those, and let's remove the debug trait because we don't need it anymore. And then we can remove that from over here. Yeah, because we don't need it. Just want the minimal set of traits on that. Okay. And now we can restore other tests. And we're in a good place to make a commit, I think. So that was fun. Like, we added range scans. They're not super efficient. But the next time we could probably go down deeper and start to take advantage of the fact that the individual files in each level can be range scanned themselves, like at a deep level. So that's a nice optimization that we can make. This is a good place to make a commit. Let's look at what our difference is. And actually, I'm going to use lazy git because I'm feeling lazy today. Okay, so we introduced range scans at the top level. We did all the crazy implementation that we had to deal with in here, right? And we added a test for it. Okay. Okay, so this is session, we're on 21, I believe. Yep, we are. Initial version of range scans. Pretty cool. Again, this is not super efficient, and I think what we'll do next time is we will go in there and we'll take advantage of the fact that those files have hierarchy to them, so we could potentially gain a bunch by not like skipping over entire blocks, which will be really interesting to put into the tree iterator. So good stuff, and we'll see you next time. Thanks for coming.